afternoon. Hope you all had a good lunch. We are now going to commence with the next presentation by Mr. Fabrice Marie. Allow me to please introduce him. Fabrice is the manager of FMA RMS, a small dedicated security consulting firm based in Singapore. Developer by trade for many years, he has been involved in the information security field for over 7 years. His interests are in secure programming, cryptography, open source, and firewalling techniques. For the last few years, he has been breaking mostly bank and telecom web applications in the Asia-Pacific region, as well as performing penetration tests for them. Originally from France, Fabrice has been staying in Singapore for the last 6 years. And today he will be presenting to us Application Intrusion Prevention Systems, a new approach to protecting your data. Ladies and gentlemen, join me in welcoming Fabrice Marie.
Thank you. So the whole goal today basically is to present some new technologies that are not ready yet. Will be ready soon. There is a big gap on the market right now in terms of application security. We'll see why it's important and why there is a gap. And the whole goal is to present technology that will effectively stop application attacks when properly implemented. Right now, people tend to forget that application security is extremely important. When you look at the amount of money spent on each layer, you quickly realize that application is the one on which you spend the least. Having said that, it's not quite true. You pay your applications millions of dollars, and yet you don't secure them, you don't care. You just put them there, get some crappy implementers to put it in place for you, and then it just doesn't work. So $1 million application that doesn't work is a bit expensive. And when it works, it won't be secure because you didn't audit it and things like this. Why do we want to hack web applications? It's very simple, because we can. It's as simple as this. It's not because you are who you are, we don't care. We do it because it's possible to be done. Full stop. And remember, applications are extremely important. If you have applications in the first place, it's because you need to take care of the data. That's why you have computers in the first place too. Network is totally irrelevant. You don't need a network to run half of the applications you're running. It's just today they are networked. So today we have more vulnerabilities due to that. Why do we want to hack the web applications? It's also because it's a lot easier to hack than through the network. I mean a normal network-based attack. On a normal network-based attack, you would have to penetrate the firewall, penetrate the systems, escalate your privilege, find a way to perform your fraud, perform it, and hope for the best. And if you're not caught by then you're very good. Whereas on the application, we don't need to do all this. We talk to the application directly. We pervert it to do exactly what we want, as opposed to what it wants. And by brutalizing it a little bit, we just get what we want. Remember, attacking applications is generally simple, provided you know how to program and things like this. If you do, then that's very straightforward. The main problem in application right now is that there is not enough knowledge, basically. Gartner found out that there's about 32% of Java developers who have a genuine knowledge of the language. 32% worldwide. So for all the rest, sorry for you. But don't laugh, those are the guys who write your applications. Those who are good are not working around here. I don't know where they work, I haven't seen many yet. I would say that it's less than 32 actually. And when they say 32, it's just genuine knowledge. It doesn't mean they know anything about security. It means the guy can code in the first place. So basically, yeah, programmers are just under-skilled. Real programmers don't exist anymore. They don't even know how memory functions. Remember, you have control over your network because it's building blocks, a firewall here, a hub there, a switch there. It's all generic appliances, but it's not the case with applications. Applications are growing massive and complex, and the more complex it is, the more flaws you're going to find. Of course, why we want to hack web application is, of course, to make money out of it. Why not? That's always been the holy grail of any attack. Fraud or laundering money, stealing, things like this. I presented on hacking internet banking last year. a quick recap of what we said last year. This is typically what you find on a bank application. This is no bullshit. This is based on 17 or more applications we've done last year. I was lazy to update the statistics for this year. It takes quite a bit of time to update the statistics. So basically all your horror becomes true. Whatever you thought that the bank is good at protecting your money and everything, it's exactly the opposite that is happening. It is, they are the most trivial systems to attack, and the most trivial system to steal money from, of course, because they are dealing with money in the first place. A web application that takes care of, for example, booking a conference room, you won't be able to steal no money from it. It doesn't handle money in the first place. So you need to find a good target application that does a function that you could possibly pervert, and then you pervert that functionality to act the way it should for you and not for the owner. So yeah, we steal money, we look at your credit records, everything. It doesn't mean all the applications have all those bugs, no, but I have some statistics broken down, and the interesting one is, for example, every single application you could steal money from. So if you look at stolen money, it's this one here. It's only 9%, but 9% globally. And still, in each application you had at least one such bug. So it's scary. It means every single bank could have been defrauded. For the stealing personal information, it's the same. It's a privacy matter. You can sue the bank for leaking your records. And it's the same. Every single application, where is it? Every single application had such a problem. So this is just to cool you down and take me seriously. You know? It always works. So now, there's two ways to go about it security-wise. You can prevent the attack in the first place, which is not happening, and you can detect. This is what IDS do. So why do we want to bother with detection? It's very simple. If the application was so good, we wouldn't care. The only reason why we still want to detect, even if the application is super secure and cannot be hacked, is because we want to find out who is trying in the first place. I don't want to have some kiddies playing against my application trying to break it, even though it's not breakable, imagine. I just want to stop them from doing it in the first place. But before you can take action, you need to have detection. If you don't know the guy is attacking you, how can you stop him? Why do we want to bother with detecting and taking action? It's because we want to sue people, of course, why not? You want to stop him, a good way to stop him is send him a legal letter and he will stop. Or send the police after him, he will also stop. We can't do this with network attacks because of the complexity or the simplicity of the protocols, in which case it's very hard to track down who did the attack. And of course the proof will not be held in court. Whereas for application it's trivial. Most of the application attack you need to be already logged on the application. So we already know who you are. So as soon as we detect the attack, we can already send the police on its way. So for now, some applications, very few, I've seen one so far that almost had no flaw. Very few stop attacks, as in prevent us from attacking in the first place. But then they don't stop us from trying. This is the whole point of what we want to do. So what's the problem with modern IDS technology? You know, everybody working in a large company has an IDS running somewhere. They have no idea what it does, but I will explain you. Basically what it does is that it looks at symptoms of successful attacks, or attacks for those lousy IDS. A good IDS will look at successful attacks. A bad IDS will look at any kind of attack. It looks at the symptoms. It doesn't look at the attack. It knows nothing about attacks. So some symptoms of a network attack is, for example, if you have a guy executing a remote shell on your machine from another country. That's obviously an attack. And things like this. For application, it's a lot harder. How do you define an intrusion? How do you know whether I transferred money from my account to somebody else's account, or if I used your accounts as the source? The IDS wouldn't know. So right now, modern IDS can potentially detect some of those classic ones: SQL injection, cross-site scripting, all sorts of overflow and brute forces. Those really basic attacks. Those attacks are useless. Don't get me wrong, I mean, they can get you some stuff, but you're not going to steal money from the bank, so I'm not interested. I'm interested by real results. And real results are generally achieved by logic flows. Like I say, you just use a functionality that already exists, like fund transfer or things like this, and you just pivot it to transfer to you instead of from you. So what do we propose? Very simple. We propose two similar technology, but a little bit more geared to one application. We propose a network-based application intrusion detection or prevention system, and a host-based one, as in an application-based one, based on a framework itself. So if you were to do a network-based ideas for application, it would have to be generic. It wouldn't know anything about your application. It would know only about the communication protocols, and therefore, as such, would be able only to catch basic attacks, those classic attacks, those generic attacks. Like I say, the interesting thing with applications is that attacks are not generic. Otherwise, you would see a lot more interesting talks on it, giving you an exact way of hacking it that always work. But you can't do this because it's very specific to each application. So that's why we also propose an application-based one, a host-based one, which is basically a framework that developers will use and put constraints into it that the framework will later check. So what would be a network intrusion detection or prevention system? It would typically be a proxy, as simple as this. Of course, it would have to be better than the regular proxy that exists today. The proxies that exist today just proxy. They take the information from the left, put it on the right, and vice versa. So it's not much use. We want to do something like this, but we want to validate every single step while we do it. So the advantage of a network IDS is that it protects even your legacy application. It doesn't care what application is behind. So the advantage is all of you already have applications deployed. A network application IDS at least would protect those, or at least would try. A host IDS, on the other hand, would be a lot more comprehensive and a lot more accurate. Problem is, it can only protect applications that were written with it. So what's the main goal of this talk? It's very simple. The main goal, you will see, I will go at great lengths at it, is really to differentiate between an attack and anomalies. Okay, this is the holy grail of every IDS. You want to avoid what we call false positive and false negative. In other words, you want to avoid a crying wolf, and you want to avoid having attacks that are not detected. So how do we do this? Basically, we will look at exactly how attackers, whatever hat they wear, how do they attack applications, and see, can this be considered purely an attack, or could this be considered an attack and an anomaly, in which case we can't take any action on it. So first things first, sorry, I'm a bit sick. First things first, we'll look at the typical dialogues or widgets that you have in web applications. Typical web applications always have the same widgets, fields, drop-down list, menus, everything, you name it. So there is basically two categories. You have those free-form one, which is, for example, please enter your name. I don't know your name in advance, so I cannot restrict you on it. And you have some that give you a choice, a limited choice. I already know in advance that you will choose one of those. Those are radio buttons or drop-down list and everything. Okay, so for example, if we take this mini bank mini application just to play with banking, this is free-form, the amount. I don't know in advance how much you want to transfer. However, I know you will transfer from this account or this account. Why is this important? Is because later I want to verify that you didn't mess with this, because you're not supposed to mess with this. So supposedly, restricted parameter cannot be changed. In other words, if you were a normal user and you just use a browser, you are limited by this choice and this choice only. The fact is, of course, an attacker can modify those. An attacker will not use the browser just like this. It will use what we call an interactive proxy.